It's a function that is defined on defined by different rules on different intervals. That means it has different equations graphed on different domains. There's different little pieces of it, different equations graphed on different domains. It still can pass the vertical line test. It can still be a function. So you can actually see on this one we've got 3 different equations in this f of x piecewise function. Here's the whole piecewise function. We've defined it with 3 different equations here. Those are just little linear functions like you do in Algebra 1. And then on the right-hand side is the domain of those equations. So the right is the domain, the left is the equation. So what I usually do on these is I just make sure I understand what interval they're graphed on. The first one is only when, how do I read this? X is less than -1. Sometimes people struggle on these because they don't know the difference between a less than and a greater than. The second one exists, this is actually, I'm going to read this as between. It exists between -1 and 2, but greater than or equal to on the -1 side. And then the third one exists when x is, how do I read this one? Greater than 2. We do use a lot of open and closed dots on these. If it's a greater than or equal to, you'll use a closed dot. If it's just a greater than, you'll use an open dot. So I'll usually graph the linear function, normal, little slope, y-intercept, just like normal. And then I'll adjust the domain as needed. Like I actually usually graph the whole thing and then erase the part that's not in the right domain until we get really good at this. Like as a professional, I can usually visualize it. But as a newbie, sometimes it's hard to visualize it. So I usually will just graph the whole thing, erase the part that I don't need, and then adjust the endpoints for open or closed. So you can see this one right here is the one that only exists less than -1. Okay, because it's the left of -1. The middle one is the one that exists between -1 and 2, where it's equal to, hold on, we got to adjust one of them. Less than or equal to. There we go. Thanks, chat. Thanks for nothing, chat. Okay. Where it's less than or equal to on both sides. And then the third one is the one that is just greater than 2. Greater than 2, because it exists to the right of 2. So again, get your pencils ready. Let's look at one together. This one only has 2 equations. Okay, the left side is going to be the actual equation part of it. Okay, the right side is the domain. Okay, I'm going to draw a little line here to separate the 2 of them. Okay, I'm going to start by just writing these as normal equations. So this top one, how you saw in Algebra 1, that's y equals -2x plus 1. The bottom one is y equals 5x minus 4. Do y'all remember how to graph these type of equations? Okay. For the first one, what's its y-intercept? 1. Very good. Y-intercept. We'll plot that first. Okay, and then its slope is just -2. Remember, that's always, anytime it's an integer, you're going to put it over 1. And then that is a measure of rise over run. So if you're rising -2, what are you doing? Going down 2. And if I'm going to the 1 run, I'm going to the right 1. So from the point that we already plotted the y-intercept, we're going to go down to right 1, put a point, down to right 1. If I wanted to point in the other direction, what could I do instead? Up 2 left ones. It's on the same line. Good. And then again, like I said, I usually will graph the whole line first and then adjust it as needed. If you have your ID badge, it helps make nice straight lines, or you can use a response card to help make nice straight lines. Anything to not get wiggly lines. Okay, so the equation that I graphed here, this right now, its domain is all real numbers. It's left forever, right forever, all real numbers. But again, what do we want the domain to be? Just when x is less than or equal to 2. So I'm going to show you right where 2 is. Okay, so if you look up here, right here is right where 2 is. Okay. Which side of this graph do we want to keep then? Which side of this would be less than or equal to 2? The left or the right side of it? The left side. So we want to keep the left side because this is less than or equal to 2. We want to erase this part on the right. We don't need that. That would be greater than. So anything greater than the 2 will erase. Okay, do I have the appropriate endpoint for less than or equal to 2? Yes, it should be a closed dot, and I already had it as a closed dot. So that one officially looks good now. Same thing for the second one. I'm going to go through and figure out what all I'm graphing. What's its y-intercept? -4. Okay, I'm going to plot that first. -4, 1, 2, 3, 4. Okay, and then its slope is 5, which remember, anytime you have a whole number, put it over 1. And then I'm going to count which way and which way for 5 over 1. Which way first? Of 5 and right 1. Don't say over, that could be any direction. Of 5, right 1. Of 5, right 1. From where you started. 1, 2, 3, 4, 5, right 1. Okay, and then I'm going to go back and adjust the domain. If you want to wait and draw your line after you figure out the domain, that's okay too, so you don't have to have eraser marks over the whole thing. But that is, right now it's all real numbers. It's left forever and right forever. But if we read the domain again, what does it need to be? Just when x is greater than 2. Again, I'm going to kind of put my ruler right where x is 2. Here's where it is 2. Which side of this do we want to keep then? Keep the left or keep the right? If we need greater than. If we need greater than, we want to keep the right, because all of this would be greater than. Everything on the left would be less than. So which side am I going to erase? The left. If you're struggling on left and right, remember you can do the L on your hand. Erased part of my old line. I'll put it back. Okay. Now adjusting the endpoint. Right now I have a closed dot. Is that what it needs to be according to x is greater than 2? No, it needs to be an open dot. I'll adjust it. And there we have our beautiful little piecewise function. Does it pass the vertical line test? Yeah, because if you put a vertical line here, it's only going to hit 1 point. Alright, I'm going to switch back to my pen now so I can answer the questions on the left. We're asked to then find some values. Now some of these you might be able to see in the graph. Some of them you might have to use one of the equations for. Remember, the number inside the parentheses does represent an x value. So we want to look at the two domains and say, would -4 be when x is less than or equal to 2, or would it have been when x is greater than 2? Is -4 less than or equal to or greater than 2? It's less than or equal to, so we're going to use the top equation to evaluate this one. So my top equation is -2 times the x value plus 1, which is 9. You probably could have seen that on the graph if you drew a nice looking graph. -4, 9 would be up here. Okay, for the second one, f of 8, remember that is just an x value again. Would that fit when x is less than or equal to 2 or when x is greater than 2 for f of 8? Greater than, so we're going to use the bottom equation for that. Alright, bottom equation says 5 times the x minus 4. So 5 times the 8 minus 4, that would be 40 minus 4, which is 36. Good job, Harvey. I'm going to have you do the bottom one and then put your answer on a whiteboard. You might even be able to see it just by looking at the graph. F of 2. Write that answer, put it on a whiteboard. I'll give us 30 seconds. All right, everybody find a number. 5, 4, 3, 2. Put that number on the board. Nice. Excellent job. Gotta get out of. What is that called when you look at the stars? What is that tool you use when you look at the stars? Telescope. I need a telescope for Bert's answer. It's so far away, so tiny. It was -3. You could actually see this one just by looking at the graph. You can see this point right here. F of 2 was this closed dot down here at negative 3. But if you wanted to use an equation, you could use the top equation and get the same answer because it's less than or equal to 2. All right, flip it over. Let's do another one. The one on the back has 3 equations. Works the same way though. They're given on different domains. Again, the left part of it is the actual equation. The right part of it is the domain. Again, I like to start by just writing them as actual equations, how we're used to seeing them in Algebra 1. The first one would be y equals negative x plus 1. And then we have just y equals 3. And then the bottom one is y equals 3x plus 4. Okay, for the first one, what's its y-intercept? 1. Let's plot it. Y-intercept at 1. Okay, now a slope, it just says negative for the slope, which would be negative what number? 1. Negative 1 over 1, which means we're going to count which ways and which ways? Down 1, right 1. Down 1, right 1. Down 1, right 1. Or if I wanted points in the other direction, what would I need to do to go the other direction? Up 1, left 1. They're on the same line. You can go backwards. Okay, I'm going to try and do this one without graphing the line first, but just keeping my dots there. So this one needs to exist. Let's read that together. What inequality is that? X is less than negative 3. Not 3, negative 3. That's a common mistake. People will do 3. So negative 3 is over here. Here's where negative 3 is. Okay. I don't have quite enough points. I'm going to go the other direction a little bit more. Here's right where negative 3 is. Which side of this do we want to keep then? The left or the right? Keep the left. The left is less than. So we're going to erase anything that's to the right of that negative 3. We'll keep the to the left of it. And then we'll think about our endpoint and see if our endpoint is right. Okay, it should just be x is less than negative 3. Do I have the right endpoint? No. What do I need to adjust it? Open dot. Open dot on at negative 3. Okay, second one. It just says y equals 3. What type of line is that? Horizontal line. Good job. Thank you for not saying straight, because they're all straight. This is a horizontal line. Okay, the most common mistake when graphing a horizontal line is everyone puts it right here. They put every horizontal line right here. But that's not where y equals 3 goes. Where do I need to adjust it to? Up to 3. It needs to be on 3 on the y-axis. So you'll have your horizontal line here. Okay. Now looking at the domain, this is one where it's kind of sandwiched in between 2 numbers. So again, I always read this as between. It needs to be between negative 3 and 0. Between negative 3 and 0. Okay, so here's where negative 3 is. Here's where 0 is. Okay, so I need between these 2 numbers only. So I'm going to erase basically 2 sides of it. Anything to the left of negative 3, gotta get rid of. Anything to the right of 0, gotta get rid of. So you only are left with the tiny little part that is between negative 3 and 0. And then let's adjust some endpoints. On the side with the negative 3, do I need an open or a closed dot? Closed on negative 3, yeah. On the side with the 0, do I need an open or closed dot? Open. Open on 0. Looking good. Would y'all like to try the last one, and then we'll do an ink pair share? You graph it, then we'll pair up and share with a buddy. Okay, ink pair share on the 3x plus 4. Alright, let's take a minute, see if we can get it graphed, and then we'll pair up and share up. Pair up and share up. just start by graphing it like normal, just how you did in Algebra 1. Extra. Alright, looks like we're all done. Let's go ahead and find a partner to share with. If you want me to assign, I'm going to say purples and greens, pinks and yellows. Or you can just find one yourself. Purples and greens, pinks and yellows. A cool to share with. Even more Oh, I might have gone. I must have gone through. Set of 6. Another set of 6. Okay, let's look at what it was. It should have a y-intercept of 4 and a slope of 3. 1, 2, 3 over 1. Okay, it should exist when x is greater than or equal to 0, which just means this part of it right here. Ta-da. Okay, closed dot on this side. Everybody get that? Correct dot. Okay, I'm going to have us do whiteboard for the next 3. Now let me know the trick on how to do these. So whiteboard for all 3 of these, you're going to end up with 3 answers on a whiteboard. 3 numbers on a whiteboard. Give you about a minute to find those 3. Again, you can find it by looking at the graph for some of them, and then if it doesn't fit on the graph, you can always plug it into the equation that has the right domain. Alright, once again, we should have 3 numbers on a whiteboard at the end. Alright, let's see those board with your 3 numbers. 3 numbers, 3 numbers, 3 numbers. Okay, looking good, like 99% right so far. What's the first one say? This feels like an eye test. Alright, correct answers were 5 for the first one. F of -4 is 5. You could actually see that one on the graph. If you go over to -4, 1, 2, 3, 4, 5 is where that point is. F of 0, you could also see on the graph. That one is 4. You see it right here. That's this point. F of 1, could we see that one on the graph too? Yeah, F of 1 is this point right here at 7. 5, 4, 7. Level up. Level up. Next section, we're going to go backwards. We have the piecewise graph already. We want to put together the correct function with its correct domains. Let's look at the first one together. Okay, so I see I have 2 linear functions. One is obviously horizontal. We've got this left side over here has a, is this a positive or a negative slope? That's a negative slope, good. Okay, so this one only exists to the left, this one only exists to the right. Let's put together a function. I'm going to start by writing f of x equals, and then a giant squiggly bracket where I'm going to be writing in my 2 equations. Do you want to do the sloped line first or the horizontal line first? Sloped line. Okay, for the sloped line, what's its y-intercept? See the y-intercept? 0. Y-intercept is 0. Good. And then its actual slope, if we did down 1, right 1, down 1, right 1, what's its actual slope? -1. Yeah. So putting that together as an equation, we would say, you could say negative x plus 0, but do we really need to write the 0? No. So we're just going to have negative x or negative 1x. Because its rise over 1 would be negative 1 over 1, which is just negative 1. Okay, for the second one, horizontal lines, remember, that's just going to be a number. What number? 2. Okay. Let's adjust the domains now, because right now if we write it just like this, we're saying they both exist everywhere, but they don't. Starting with this one, I can see its endpoint is at 0, but is that x is less than or equal to 0 or greater than or equal to 0? Less than or equal to 0, because it's to the left of 0. So when x is less than or equal to 0. What about for the second one? Greater than 0. Why not greater than or equal to? Why just greater than 0? Open dot. All right, second one, same thing. What's different about the second one though that we haven't seen on any of these? None of the ones we've done so far, we've seen this. They're like together. They're connected. Yes. When they're connected, you're going to say one of them is an open dot and the other is a closed dot. Not both. They can't both be closed. One's open, one's closed. It doesn't matter which one you say is which though, as long as you have one open and one closed. You know, I asked that and I got an answer that just said they can't exist both at the same time, and I was like, okay. You'll see it on the next one too. It's always one open, one closed. All right, let's write our equation. Be careful of the scale on this one. What does the vertical axis count by? 4s, right. 4, 8, 12. What does the horizontal axis count by? 2, 4, 6, 8, 10. Very good. All right, let's start with this little guy down here. What's its y-intercept? 8. So we know we're going to have a plus 8. And then if we count its slope to get from one point to the next, what is its rise? 4. What is its run? 4. And 4 over 4 would turn into 1. So 4 over 4x would be just 1x or x plus 8. Okay, second one. Can we see the y-intercept right now? You can see the y-intercept for the second one? I can't. Okay. Can we see the slope? Can we count the slope? Yeah, we can count the slope. Let's count it. Be careful what you count by. Okay, be careful what you count by. We're going to start with our rise. What is that rise? That's a rise of 8 because the lines count by 4s. Good. What is the run? 2, because those lines count by 2s. So if I put it together, we'll have y equals 8 over 2x plus some sort of y-intercept that I don't know. 8 over 2 is going to simplify to 4x. Okay. Now there's two ways we can do the y-intercept. If you want to, you can use point slope form. Plug in the slope, plug in a point, simplify it, get your slope-intercept form. You can also just use the slope and kind of complete the rest of the line, like figure out where the line continues to find the y-intercept. I'm going to do it that way. So I'm going to continue my line and go down 8 over 2, down 8 over 2, down 8 over 2. So here's where the rest of the line would be, making the y-intercept at what number? -4. I'm going to fill in that equation, 4x minus 4. I know, they're a little tricky. Now remember, when you do your inequalities, one of them make an open dot, the second one make a closed dot. It doesn't matter which one you put as which, both would be correct. For the first one, I can see it's to the left of 4. To the left of 4. Okay. Do y'all want to say, would that be less than or greater than? Less than or greater than, everyone? Less than. Good. Do y'all want to make this one less than or less than or equal to? It doesn't matter. Less than? Okay, so then we'll make the other one the greater, or the or equal to, excuse me. Okay, for the second one, this one exists to the right of 4. Would that be less than or greater than? Greater than. So we're going to say x is greater than or equal to 4. One's open, one's closed, but when you see it, say it again. Oh, because it's not like a set notation. I know. All right, bottom one comes to an AP classroom. We have this kind of V-shaped looking graph. It says the graph of f of x is shown in the xy plane. This is a piecewise graph, but it's similar to the last one where the two pieces kind of connected, and so one will be open and one will be closed. Which of the following equations represents that piecewise? I'm going to have you guys do a little table talk on this one, and then we'll do a quick response for the final answer. That means you're just going to give me a show of fingers for whether you think it is A, B, C, or D. But let's talk about it in our tables. What is the slope? Which ones can we mark off based on the slope? Which one has the correct domain?
Yeah, what he said. Can't be 0 or D. That's like last time. The identity is before on it. I don't know that you feel like it's pretty good. Alright, the higher still strong. You still trying to do this. You know the allegory of the cave? Me and Marie have seen the sun. They're still trying to come out of the cave.
No, once you know how they work, yeah, not bad at all. Sean, you got an answer already? Checking. So Hasra, did y'all get an answer? Y'all's group got an answer? Sterling, y'all got an answer? It doesn't have to go on a whiteboard. We're just going to do a quick response of fingers. Julie, is y'all's group still working? Okay. They have a test review today. No, yeah. Okay, Reba, you got an answer now? Show your answer. Okay, let's do a show of fingers. 1 finger if you thought it was A, 2 if you thought it was B, 3 if you thought it was C, and 4 if you thought it was D. A, B, C, or D? It was A. 1 finger. Just based on counting the slope, which answers did you mark off? C and D had the wrong slope. It was up 2 over 1. Okay, and then I noticed this positive piece was only to the left of 0. So that would be this one right here. X is less than 0. Whereas this one shows the negative piece should be less than 0. I guess if you didn't know it was on the domain, you might get confused with that. Okay, what time is it?